This lab considers the interaction between potentiometers and motors. The potentiometers will be used to control the speed or location of different types of motors. Motors are used in a majority of mechatronic systems. Any system that will need to move will need a motor and a controller for that motor. In this assignment, you will be building simple controllers for the DC motor and the servo motor. This is the DC motor. It uses electromagnetic coils to create rotational force that turns a rotor. This is a servo. Servos are DC motors that have integrated gears, position feedback, and control. This is a potentiometer. They are variable resistors that can be changed by twisting the knob on top. This is a transistor. A transistor is a semiconductor device used to amplify and switch electronic signals and electrical power. The 3 pins on the transistor are called the base, collector, and emitter. This is a diode. A diode has low, ideally zero, resistance to current in one direction, and high, ideally infinite, resistance in the other. This means current is allowed to flow in one direction through the diode. For this assignment, the Arduino will send and receive signals. The signal received will come from the potentiometer, while the signal sent from the Arduino will be used to pulse the motor. The potentiometer will send a voltage value to the Arduino. This value will then be read by the code and converted to a pulse width modulation value between 0 and 255. Pulse width modulation is when a motor is sent pulses of power to limit the speed and power output of the motor. The longer the pulse, the faster the motor will spin. Now, the Arduino will send the pulse to the transistor, which closes the motor circuit, allowing the motor to spin. The diode now inhibits the motor's ability to turn into a generator while the motor is off. This reduces feedback to the transistor. The servo works in a similar fashion as the DC motor. Instead of potentiometer controlling speed of the motor, it will now control the position of the servo. There are not many components in this circuit due to most of the controls being held in the housing of the servo motor. The position of the servo is determined by the same pulse width modulation in the DC motor. Now the length of the pulses determines the position. The servo motor library does this for you. It is often useful to see what the Arduino is doing by communicating via the USB cord. This is done using the serial library. To set up the serial communication, serial begin must be put in the setup. Serial print allows the user to see desired values. The map function is essentially a ratio function. In this application, it converts any value from 0 to 1023 to a value between 0 and 255 proportionally. The input from the potentiometer ranged between 0 to 1023. The PWM function of the Arduino requires values between 0 and 255. This is why the map function had to be used. The constraint makes sure that a variable remains between 2 values. The sensor value takes the potentiometer voltage reading and output as an integer between 0 and 1023. The map and constraint functions convert it to a PWM value between 0 and 255. This value is output to the motor circuit by the analog write function, spinning the motor. The servo library is included, and the servo defined by the lines servo my servo, and in the void set up by my servo attach, is the pin that controls the servo. The main loop reads the potentiometer voltage as a value between 0 and 1023. This is converted to an angle value by the map function. The servo H library takes this angle and sends it to the servo. The servo then moves to this angle.